So the next part, after you guys finish that table, is we're going to change our goal. Instead of giving us the amount of tickets and solving for a dollar amount, what is going to happen if I said that our goal is to raise $200? Well, now we need to determine the amount of tickets. And the number of tickets is X, so we're going to replace 200, or Y with 200. So, and when we do that, we have Y is equal to 2.5X. And now I want to know what happens if this is 200. So 200 is equal to 2.5x. So now we need to solve for x. And I'm sure that you guys know how to do this one. It's a simpler one, yes, I understand that. But we work through the easy ones this way so that we can prep ourselves for when they get more difficult. And there's 3 different methods that we can use to solve this. And you need to write these down in your notes. 3 methods. Method number 1 is going to be to solve it numerically. Method number 2 is going to be to solve it graphically. And method number 3 is going to be to solve it algebraically. And we're going to go through each of these methods so that you know what each of them entail. Method number 1, numerically. We're going to use a table of values to estimate how many tickets must be sold to raise $200. So we're going to begin by estimating a value for x. So our expression is close to 200, and so I'm just going to start with an easy one, and I'm going to go with like x is equal to 100. So this is our equation, by the way, from I'm going to make a table of values.
Hey.
Okay. So we're going to use this table to estimate how many tickets must be sold. And like I said, I'm just going to estimate, and I'm going to do 100 right away, just to see what we get, which is pretty obvious. If I put 100 in for x, 2.5 times 100, I'm going to get 200. So I'm going to say 100 times 2.5 is going to give us 250. So now that I have guessed that, I need to either increase or decrease my value, depending on which gets us closer to our outcome of 200. So obviously, 100 is too big, so I'm going to move it down, and I'm going to put a guessing of 70. And if you go 70 times 2.5, we're going to get 175. Now, 175 is too small, so I know it has to be bigger than 70. So we've got to narrow down this between 100 and 70. So I'm going to jump up to 90 once. If you go 2.5 times 90, that's going to equal $225. And again, your guesses can be anything. They do not have to be the same as mine. I mean, you could have done 75 if you wanted to. You could have done, 91 if you wanted to. It doesn't matter. These can differ, but I'm just showing you like my example. And so my last one, I know that's between 70 and 90, so I'm going to go with 80. And then 2.5 times 80. Woo, look at that, $200. So I know that has to be 80 tickets sold. Alright, so this right here, that's solving it numerically. Do you see any problems that could occur with this? One thing, it can take a lot of time, and especially if they're not a nice whole number like this, like when we're dealing with decimals, it can take a real long time to guess it, check it, and then do that again until you find the right answer. So not quite the best method. So now that we've solved this numerically, now we're going to solve it graphically. And if I was told that we know that these points, we know that there's 20 tickets sold, there will be an income of $50. There's 40 tickets sold, we'll have $100, 60 is 150, and 200 is 500. And I was told to solve how many tickets will be sold at $200. So we're still searching for 200 is equal, 200 is equal to 2.5x. So I want to know what's our x going to be at 200. And so I'm going to plot these points. So at 20, it's 50. 40 is at 100. 60 is at 150. And then 200 is at 500. So now that I have those plotted, I can connect them with a line. And we're going to use a straight edge so that it's an accurate line. Make sure you guys are doing the same thing. Oh, I was supposed to hit 100, my bad. Oops. Mine's going a little haywire. Alright. So there's my line connecting all of them. And now what I can do is I can look and see where is 200 at, because this is talking about dollars sold. So where does 200 connect? Here. Look at that, right here, this point, which is 8,200. So then I know that x is equal to $80. So this is method number 2, solving it graphically. And one really big advantage of doing it this way is that we can see so many other values, like without having to solve for them after we graph it one time. You know, if I said, how many tickets do I have to sell to get $400? Well, then you could just know where do those points line up, and then you could just check it out that way. And so on and so forth. If I ask for any, amount, we can just look at our graph. But one big disadvantage of this, and you almost thought I plotted one of the points in the wrong spot and would have had a really funky line, is that it's so easily to graph this incorrectly and to make just one small error and to not draw your line straight. And so we gotta use a straight edge. So there's a lot of human error that can occur here, which gets you the totally wrong answer. Alright. Now finally, we're gonna solve for this last way, which is algebraically. Number 3. I might have butchered that spelling, to be honest. So we have 200, back to our original equation, 200 is equal to 2.5x. And all we're doing here is solving for x, which I know that you guys know how to do. So if I divide both of these sides by 2.5, so I want to isolate x, and I'm going to do the inverse operation of what's happening right here in between these, and they're being multiplied, so I need to do the opposite of that, I'm going to divide. So both sides divided by 2.5, these will cancel out. I'll just have an x over here, 200 divided by 2.5, I wonder, I bet it's 80. So then our answer is 80 equals x, so 80 tickets. 80 tickets is our answer.